Good morning, students. Palkana Namaskar. So, in the last class, we have completed the first chapter, rotational motion. We have solved the numerical problems. So, today, let us start a section, that is, we have different sections: properties of matter, heat, sound, electricity, like this. So, let us today start a sound section. In sound section, today we are going to study superposition of views. Superposition of views. Superposition of views. So in the 11th standard, we have studied what do you mean by view, what do you mean by sound. Let us recall it. लॉकडाऊनमुळे आपण बरेच 5-6 महिने झालं त्या अभ्यासाच्या टचमध्ये नाही. काही विद्यार्थी आहेत, काही विद्यार्थी नाही. त्यांच्यासाठी आपण काय करू, 11वीत जे शिकलेलं आहे त्याचं थोडंसं आठवण करू. सो व्हॉट इज साऊंड? साऊंड म्हणजे काय? व्हॉट डू मीन बाय साऊंड? सो वी हॅव डिफरंट टाइप्स ऑफ एनर्जीज. Potential energy, kinetic energy, heat energy, sound energy. So sound is a form of energy. Heat is also a form of energy. Some energies create sensation in our sense organs. Like heat energy creates sensation in sense organ. You have different sense organs: nose, eyes, ear, skin, tongue. 5 sense organs. So heat energy is detected by the sense organ skin. Similarly, sound is a form of energy which creates sensation in sense organ, namely the ear. कान. समजा एखाद्या ठिकाणी आपल्याला आवाज निर्माण होलेला आहे आणि तो आवाज आपण डिटेक्ट नाही केला तर म्हणणार की आवाज नाही, देयर इज नो साऊंड. डिटेक्ट करायला पाहिजे. तो आवाज येऊन आपल्या कानावर आदळल्यानंतर तो आवाज डिटेक्ट होऊन ब्रेन पर्यंत पोहोचणे आवश्यक आहे. आणि ब्रेन पर्यंत पोहोचलं की म्हणतो की आपण आवाज आहे, नाही तर नाही. So, sound is a form of energy which create sensation in sense organ, namely the ear. A human normal ear, I am not talking about human normal ear, can hear a frequency of 20 hertz to 20,000 hertz. 20,000 hertz. Normal ear, not abnormal ear. A human normal ear can hear a frequency of 20 hertz to 20,000 hertz. This range of frequency is called audio frequency range. Audio frequency range. Audio frequency range. Frequency greater than 20,000 hertz. Greater than 20,000 hertz are called ultrasonic sound. This frequency greater than 20,000 hertz cannot be detected by normal ear, human normal ear, but this sound, ultrasonic sound, can detect by a bat. So this is what is sound. So sound is a form of energy. Energy transfer from one medium to other medium. The transfer of energy takes place in the form of wave. Once again repeat. Sound is a form of energy which creates sensation in sense organ, namely the ear. A human normal ear can hear a frequency of 20 Hz to 20,000 Hz. This range of frequency is called audio frequency range. Frequency greater than 20,000 Hz are called ultrasonic sound. A bat can detect ultrasonic sounds. So the sound energy propagates through the medium. Sound energy propagates through the medium in the form of wave. Then what is wave? Wave म्हणजे काय? आपण अभ्यास केला 11वीत. You are studying the 11th standard. Wave म्हणजे काय? So let us concentrate on the wave. As we are going to study the chapter Superposition of waves. So let us know first of all what is wave, then position, then what is superposition. Okay. What is wave? You have studied in the 11th standard. 11वीत आपण अभ्यास केले. Let us suppose we have a standing and a still water. Standing and still water. शांत थांबलेलं पाणी आहे. If a stone is dropped in the standing and still water, that means you are imparting energy. Potential energy and kinetic total energy. And that energy, part of energy is absorbed by the molecules of water. And because of that, molecule moves in downward direction. As water possesses the property of bulk modulus, elastic property, and because of that, molecule, it comes momentarily at rest at this position and it returns back due to property of inertia. Inertia and elastic property. And it comes at the mean position. Here it cannot stop because of property of inertia. And it moves in upward direction, or particles start to move in perpendicular direction, up and downward direction, or it performs vibration. When a stone is dropped in the standing still water, we have created a disturbance. Remember, disturbance in the water. So the energy acquired by the first molecule is secondly transferred to the second molecule. It also starts to move. Similar, all the molecules of the water starts to moving, or they starts to vibrating about their main position. And because of that, we see that ripples are produced in the water. Ripples. When a stone is dropped inside the water, what we have done, we have produced a disturbance in the water. What type of disturbance? It is a oscillatory disturbance. We have created oscillatory disturbance in the water. And that oscillatory disturbance propagates through the medium from one point to another point is called a wave. Is called a wave. Then what is wave? The propagation of oscillatory disturbance through the medium from one point to another point without change in form. Whatever it may be the form. Let us discuss this afterward. Without change in form is called a wave. Is called a wave. Once again, what is wave? the propagation of oscillatory disturbance from one point to the another point through the medium without change in form is called a wave. This we have discussed in 11th standard. So we have different types of waves. We have different types of waves. What are they? Light wave, light wave, light waves. Second, sound waves. Third, water waves. Fourth, mechanical wave. And fifth, electromagnetic wave. Let us discuss after what are the water waves, sound waves and light waves. What are mechanical waves? Mechanical wave म्हणजे काय? As just now we have discussed disturbance. To try to concentrate disturbance. What is propagating? Disturbance is propagating. Disturbance is propagating. Mechanical wave means what? Disturbance produced. Where it is produced? It is produced in elastic medium. Elastic medium. Why the disturbance is produced? Due to vibration of particles. Vibration of particles. Particles of medium. See how we are defining mechanical medium. Mechanical wave. What is mechanical wave? A disturbance produced in elastic medium due to vibration of particles in the medium which transfer the energy from one point to another point is called a mechanical wave. Or in other words, a wave which requires material medium for its propagation is called mechanical wave. किंवा ज्या वेवला प्रोपगेट होण्यासाठी मीडियम लागते. मीडियम कोणती असो? सॉलिड, लिक्विड, गॅस. तीनपैकी कुठलं जर एखादा मीडियम लागत असेल तशा प्रकारच्या वेवला आपण काय म्हणतो? मेकॅनिकल वेव. मेकॅनिकल वेव म्हणजे काय? There are two types of mechanical waves, that is transverse wave, and second one is what? Longitudinal wave. Longitudinal wave. In mechanical wave, remember, important point is while the wave is propagating through the medium, this we have studied in 11th standard, particles of the medium vibrate about their mean position. But particle itself is not carrying the energy. Energy is transferred from one point to the another point. एनर्जी आपण जिथं डिस्टर्बन्स निर्माण केले तिथून ट्रान्सफर होणार आहे. इथं डिस्टर्बन्स निर्माण केले इथून पुढे एनर्जी ट्रान्सफर होते. पण एनर्जी ट्रान्सफर होत असताना प्रत्यक्षात त्या मीडियमची मॉलिक्यूल एक पॉइंट पासून दुसऱ्या पॉइंट पर्यंत घेऊन जात नाही. मॉलिक्यूल जिथल्या तिथंच व्हायब्रेट होतात आणि एनर्जी ट्रान्सफर होतो मेकॅनिकल वेव्हमध्ये. सेकंड टाइप ऑफ वेव्ह इज व्हॉट? इलेक्ट्रोमॅग्नेटिक वेव्ह. मेकॅनिकल वेव्हसाठी मेटेरियल मीडियम आवश्यक आहे. फॉर मेकॅनिकल वेव्ह मेटेरियल मीडियम इज necessary. What is electromagnetic wave? A wave which does not require material medium for its propagation is called a electromagnetic wave. किंवा ज्या वेव्हला प्रोपेगेट होण्यासाठी मेटेरियल मीडियमची गरज नाही तशा प्रकारच्या वेव्हला काय म्हणतो आपण? इलेक्ट्रोमॅग्नेटिक वेव्स. आता मेकॅनिकल वेव्ह काही ठराविक मीडियम मधील प्रोपेगेट होऊ शकतो. त्याचे दोन प्रकार आहेत, ट्रान्सव्हर्स आणि लॉन्जिट्युडनल. पण याला काही कंडिशन्स आहेत. इलेक्ट्रोमॅग्नेटिक वेव्हला कसलेच कंडिशन नाहीत. दे कॅन प्रोपेगेट थ्रू लाईट, सॉलिड, लिक्विड, गॅसेस और व्हॅक्यूम ऑल्सो. व्हॅक्यूम मध्ये त्यांनी प्रोपेगेट, जसं सूर्यप्रकाश, आपल्याला सूर्यापासून आपल्यापर्यंत प्रकाश येतो. ॲटमॉस्फिअर एक काही 24 किलोमीटर जर संपलं समजा, एक उदाहरण, त्याच्यानंतर हे व्हॅक्यूमच आहे. तरी तिथून आपल्या सूर्यप्रकाश पोहोचतो, म्हणजे कुठल्या फॉर्ममध्ये? इलेक्ट्रोमॅग्नेटिक वेव्हच्या फॉर्ममध्ये. सो लाईट वेव्हज आर इलेक्ट्रोमॅग्नेटिक वेव्हज. तर दोन प्रकारचे वेव्ह आपण डिस्कस केले, मेकॅनिकल वेव्ह आणि इलेक्ट्रोमॅग्नेटिक वेव्ह. याच वेव्हला आपण काय म्हणायचं? प्रोग्रेसिव्ह वेव्ह म्हणायचं. ते कसं पहा. प्रोग्रेसिव्ह वेव्ह त्या चॅप्टरच्या आपण फक्त ह्या इथंच अडकलोत. अजून इथंपर्यंत आलंच नाही, मागे त्याच्या मागे आलंच नाही, वेव्हवरच अडकून आहोत. बघू अजून पुढे. पोझिशन नंतर बघू, सुपरपोजिशन पाहू. प्रोग्रेसिव्ह वेव्ह as just now we have discussed, when we drop a stone in the standing still water, ripples are formed. आता पाण्याचा प्रवाह भरपूर, आपल्याला एवढं पाण्याचं पात्र आहे समजून घेतले. आता हे रिपल्स इथपर्यंत पोहोचत नाही, तिथंच कुठं संपून जातात आतमध्येच. का? ह्याला जे आपण एनर्जी ट्रान्सफर केले, ह्याच्यातलं याला भेटेल, ह्याच्यातलं याला भेटेल, आता होता होता थोडं थोडं कमी होत होता, पुन्हा ते टोटल लॉस होऊन जातो. पुढे सरकतच नाही एनर्जी. म्हणजे इथंच कुठेतरी वेव्ह थांबला, रिपल्स थांबले, ते प्रोग्रेस झालं का पुढे? प्रोग्रेसचा अर्थ काय? कंटिन्युअसली. A wave which propagates through the medium continuously without break. त्याच्यामध्ये कसल्याही प्रकारचा ब्रेक असू नये. सॉरी, पाणी कुठे गेलं? प्रोग्रेसिव्ह वेव्ह म्हणजे काय? A wave which travels through the medium कंटिन्युअसली विदाउट डिस्ट्रक्शन, त्याच्यामध्ये कुठलाही प्रकारचा डिस्ट्रक्शन असू नये किंवा ब्रेक होणे. सेकंड, फर्स्ट कंटिन्युअस, सेकंड ब्रेक, थर्ड डिस्ट्रक्शन. A wave travels through the medium in a given direction continuously without a break and destruction is called a progressive wave. Sound waves are what? Progressive wave, or light waves are progressive. So let us study the properties of progressive wave. Progressive wave चे गुणधर्म काय आहेत पाहू आपण. पहिला म्हणतो, तुम्ही 11वीत अभ्यास केलेला आहे, तुमचा झालेला आहे, म्हणून मी काय करतो, ट्रान्सव्हर्स डायग्राम काढतो रफली. When progressive wave propagates through the medium, let us say the transverse propagating from originating from O, it is traveling from left to right. Particles of the medium vibrates about their mean position. All the particles of the medium vibrates about their mean position. Or in other words, they execute simple harmonic motion. What is simple harmonic motion? It has been taught by Shastri Madam. त्यांनी चालू केलं सिंपल हार्मोनिक मोशन चॅप्टर चालू केले, त्यांनी सिंपल हार्मोनिक मोशन डेफिनेशन दे सांगितलं तुम्हाला. सो एव्हरी पार्टिकल ऑफ द मीडियम परफॉर्म्स सिंपल हार्मोनिक मोशन, दॅट इज फर्स्ट कॅरेक्टरिस्टिक्स. सेकंड, so when the wave is propagating through the medium, observe the vibration of particles. इथं particles, direction of particles is upward direction. या पोझिशनला पार्टिकलची डायरेक्शन डाऊनवर्ड आहे. म्हणजे याचा अर्थ कसा की याचा स्टेट ऑफ मोशन ऑफ पार्टिकल इज डिफरंट एट डिफरंट पॉइंट्स. हा पार्टिकल मॅक्झिमम एम्प्लिट्यूड अटेंड केले, हे पहिले अटेंड केले, नंतर करणार आहे, नंतर करणार आहे, हे नेगेटिव्ह आहे, मॅक्झिमम होणार आहे. स्टेटलाच म्हणतो आपण फेज. स्टेट ऑफ पार्टिकल, स्टेट म्हणजे त्याचे दोन गुणधर्म येतात, त्याची पोझिशन अँड डायरेक्शन. पोझिशन म्हणजे डिस्प्लेसमेंट, डायरेक्शन म्हणजे डायरेक्शनल. स्टेट म्हणजे दोन क्वांटिटी आहे. स्टेट म्हणजे व्हॉट? इट्स पोझिशन ॲज वेल एज डायरेक्शन. त्याला म्हणतो फेज. तो फेज ऑफ ईच पार्टिकल इज डिफरंट ऑफ द मीडियम. मीडियम मधल्या प्रत्येक पार्टिकलचा फेज वेगळा वेगळा आहे, डिफरंट आहे. Third, now the question arises, when the particle is in simple harmonic motion, the maximum displacement of particle is called amplitude. Maximum displacement, इथून हळूहळू डिस्प्लेसमेंट वाढत होते तर मॅक्झिमम होतो. मग इथून इथपर्यंतचा लेंथ काय आहे? वेवलेंथ म्हणतो आपण. दिस इज वेवलेंथ. एक वेवला लागणारा टाइम टी, फ्रिक्वेन्सी एम. The amplitude, frequency and time period of every particle of the medium remains same. प्रत्येक पार्टिकलची amplitude, frequency, time period सगळ्याची सेम आहे, त्याच्यात काही बदल होत नाही. तिसरा गुणधर्म. आता चौथा गुणधर्म. फोर्थ, पार्टिकल सिंपल हार्मोनिक मोशन मध्ये आहे, व्हायब्रेट होलेले, कदाचित अजून तिथपर्यंत पोहोचले नसतील शास्त्री मॅडम. सिंपल हार्मोनिक मोशन मध्ये आहे म्हणजे त्याची वेलॉसिटी बदलत चालली आहे, म्हणजे कुठंतरी मॅक्सिमम आहे, कुठंतरी मिनिमम आहे. Particle is vibrating about its mean position. That means it should possess minimum velocity at some point. It should possess maximum velocity at some point. Other will it come at rest? Yes. And the particle in simple harmonic motion at extreme position, at this position, extreme position, particle becomes momentary at rest. काही क्षणासाठी ते थांबतो म्हणून त्याची वेलॉसिटी 0 आहे. At extreme position, particle at that point becomes 0. Fifth one, and at mean position, velocity of particle is maximum, which is equal to a omega. A, capital A. Velocity of particle is maximum. Important thing is, due to vibration of particle, energy is transferred from one point to the another point. Sixth property. Energy is transferred. Energy is transferred from one point to the another point. Seventh one is, as the wave is propagating through the medium, that means it's changing its position. The change in position with respect to time is called velocity. So velocity of wave through the medium depends upon the property of medium, whether it is solid, whether it is liquid, whether it is gaseous. Solid असेल तर कसं, liquid असेल तर कसं, gas असेल तर कसं. Velocity of particle, velocity of wave, progressive wave through the medium depends on property. Eighth one, we have two types of progressive wave. First one is transverse wave, and second one is longitudinal wave. What is transverse wave? As the wave is propagating from left to right, particles of the medium vibrating perpendicular to the direction of propagation of wave. A wave in which particles of medium vibrate perpendicular to the direction of propagation of wave. If the wave is propagating in this direction, if the particles are vibrating perpendicular, then the progressive wave is called transverse wave. Transverse. Word transverse itself, it is perpendicular. Longitudinal means parallel. A wave, a progressive wave in which particles of medium vibrate parallel to the direction of propagation of wave, or in the direction of propagation of wave, is called longitudinal wave. What are longitudinal wave? A wave in which particles of medium vibrate parallel to the direction of propagation of wave is called longitudinal wave. Examples of transverse wave are light wave, and examples of longitudinal sound waves. 10th property, transverse wave can propagate only through solid, not through liquid and gases. But longitudinal wave can propagate, only longitudinal can propagate through liquid. Longitudinal wave can propagate through solid liquid, but transverse wave can only propagate through solid. Okay. So, once again repeat in brief the properties of progressive wave. When a progressive wave propagates through the medium, particles of the medium executes simple harmonic motion. Second property, phase of every particle is different, each particle is different, the state of oscillation is different. Amplitude, frequency and time period of every particle is same. As the particle is performing simple harmonic motion, at extreme position, particle comes to momentary rest or its velocity is zero. At mean position, velocity of particle is Vmax is a maximum which is equal to A omega. As the wave propagates through the medium, energy is transferred from one point to the another point. The velocity of wave propagating through the medium depends upon property of medium, whether it is solid, liquid or gaseous. We have two types of progressive waves, transverse wave and longitudinal wave. A wave in which particles of medium vibrate perpendicular to the direction of propagation of wave is called transverse wave. Example is light wave. A wave in which particles of medium vibrate parallel to the direction of propagation of wave or in the direction of propagation of wave is called longitudinal wave. Example sound wave. Transverse wave propagate only through solid, and longitudinal can propagate through solid and liquid. Okay, what is the time? 32 minutes. Okay. Okay, we'll stop here only. Let us discuss this tomorrow. Thank you.